Okay, let's talk about section 4-2, which is on SSS and SAS. SSS means side, 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 and SAS means side, angle, side. Okay, you'll recall that in section 4-1, which we talk about proven triangles, you have to prove six congruences to prove triangles congruent. You have to prove three, you have to first prove that there are three congruent pairs of congruent sides, and you have to prove that there are three pairs of congruent angles. That was a lie. Actually, you need to prove, but in section 4.1, we said you had to prove all six. Well, in section 4.2 and beyond, you only need to prove three. And we'll talk about that today in section 4.2, and we'll also talk about that more in section 4.3. But for right now, let's talk about 4.2. Now, before we talk about that, we solve for the missing components. Notice that these two x's are equal, so I set them equal, get x equals 20, and I set the two y's equal, and I get x equals 50. Now here, for this one right here, and I'm going to go ahead and I'm going to mark that with a little line between it so you don't get them confused. Notice that the y and the 40 are vertical angles, so that means that they're equal to one another. Well, in this particular triangle right here, and I'm going to go ahead and highlight that in green so you can see it with your own eyes. So, remember, the sum of the interior angles of a triangle is always going to be 180. So this is 2x, and this is also 2x. How I know they're equal is because they both have one curve in them. Since they both have the one curve, that tells me that they're congruent to one another. So I add 2x plus y equals 180. Well, I know that y is 40, so I add 2x and get 4x plus 40 equals 180. And I solve for x, and I get 35. All right. Now, this next one was a little tricky. All right. I had an unknown angle here. I called it g. So g plus 18 plus 40, 148 equals 180. And we did the math knowing that the sum of the interior angles of a triangle is 180 degrees. So I get g equals 14. So here's what I do know. I know that 3x plus y equals g, which is 14. So I know that these two angles are congruent. I also know that 5x minus y is equal to 18 because the third angles have to be congruent. Because I know these two angles are congruent, those two angles are congruent, so that means that the third angles have to be congruent to one another. So I set it up as an algebra problem, a system of equations. And I get 3x plus y equals 14. I get 5x minus y equals 18. Add the components together, I get 8x equals 32, which when I solve it, I get x equals 14. And then once I get x equals 4, not 14, but 4. So x equals 4, I plug it back in. I could plug it into either one of those two equations. I went ahead and just plugged it into the top one right there, and I got y equals 2. And you'll get the same thing if you plug it into the bottom one. All right. Now, we talked last time about having to prove triangles congruent. I just caught a typo here, so let's make that triangle ABC is congruent to triangle RST. Then the corresponding sides are congruent, and the corresponding angles are also going to be congruent to one another. So that's what we talked about last time. If this is A, and this is A, this is B, and this is C, this is RST. So those two sides are congruent, those two sides are congruent, and then those two sides are congruent. Well, these angles are congruent, these angles are congruent, and finally, those angles are congruent. So you have 6 pairs of congruences, 3 pairs of congruent sides, and 3 pairs of congruent angles. You don't need to prove all 6. You only need to prove 3 of them. And we'll talk about what they are here on the next slide. And remember, where they lie in the congruent statement. R is first, so is A, 1 curve. B, S, 2 curves. C, 3 curves. All right. Now, postulate 4.1. Now, remember, a postulate is a statement that we assume to be true. We can't prove it. So, but it says that if the SSS postulate, it's just simply side, side, side. That's all you have to write. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So three sides of one triangle, three sides of a second, then the two triangles are congruent, as you see right there. So as long as I have three pairs of congruent sides, then my triangles are going to be congruent to one another. All right. Now the same thing goes for what's called side angle side. Now here's how side angle side works. It is labeled SAS, side angle side. Here's what it says. It says if two sides of and the included angle of one triangle congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Now here's what I mean. You have one pair of sides, another pair of sides, and the angle that is formed by the two sides, or that's called the included angle. So I have two pairs of congruent sides and the angle that is formed, then that shows that the two triangles are congruent. So here's what we have. We have side angles, we have side, 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 three pairs of congruent sides, or we have side angle side, which is two pairs of congruent sides and the angle that is formed by both sides. All right, now, next we're going to prove triangle congruence right here. And I'm going to throw in some terms that you may not be aware of, but that's part of learning. All right. First, I'm given that AD is congruent to AB and that AC bisects BD. And I'm trying to prove that triangle ADC is congruent to triangle ABC. And I'm putting them down there. All right. Now this time I gave you the statements. All you got to do is come up with the reason. But I won't always be that. You won't always be so fortunate in that aspect. All right. Now the first statement, of course, is the given. You see the given right there? So I put it right there, but I'm going to go ahead and write given. Okay. Now, here's the next one. It says that AC bisects BD. Oh, I forgot to mark this. So let me mark that real quick. So I marked that the two sides are congruent. It's important to mark the diagram as you go through it, because when you do that, it gives you a visual. It helps you see it better. Some of you are going to think, I don't need to do it. I'll remember it. Well, wrong. You will forget. You won't see it. So mark your stinking diagrams. That's how I like to put it nicely. All right. I haven't said that for a while, so there you go. All right. Now it says that AC, this segment right here that's in green, bisects segment BD. It splits it into two congruent segments. That is called the definition of bisect. I don't know if we've covered that in this class, but I want you to know that. All right. So the next thing you need to look at, I want you to know, the yellow and blue make green, so they both share a common side. They both share side AC. So AC is congruent to itself by the reflexive property. And then finally, we have proven that the two triangles are congruent by the side, side, side congruence postulate. I don't care if you say postulate, just say side, side, side. You're done. SSS, you're done. All right. All right. Let's do another one. This time we are given that BE and AD bisect each other at C, and we are trying to prove that triangle ACB is congruent to triangle DCE. Okay, so let's write that down. BE and AD bisect each other at point C. And that is a given. Okay. All right. And we're trying to prove that triangle ACB right here. And notice I'm highlighting that in yellow, and I'm highlighting this one in blue. I do that so I can show myself what I'm trying to prove. I'm trying to prove that those two triangles are congruent. All right. Now, we know that BE and AD bisect each other at C. So what that means is this. It means that AC is congruent to DC. AC congruent to DC. And BC is congruent to CE. By, just like we did in the last problem, definition of bisect. All right. Next. If you look at these two angles right here, you will notice I'm going to call that angle 1 and I'm going to call that angle 2. I'm going to say that angle 1 is congruent to angle 2 because they are vertical. So, and I'm even going to mark them up here. Angle 1 and angle 2 are vertical by the fact that they are vertical angles. All right, now the question is, do I have enough to prove triangle congruence? Well, let's look. I have side, I have the angle that they share, and the other side. So yes, so triangle ACB is congruent to triangle DCE, and that is by the side angle side congruence postulate, or just side angle side. All right. Now, I'm going to pause this for right now because we're going to come back to this. Actually, we'll come back in part 2.